Now let's go on to the second derivative. What does the second derivative tell us? Well, in our position function, velocity, acceleration, it told us about how the velocity was changing. So just derivatives, it's going to tell us how the slope is changing. So if we have an increasing function with positive second derivative, that means we're increasing at an increasing rate. If we have a positive first derivative and a negative second derivative, we're increasing at a decreasing rate. Increasing at an increasing rate, increasing at a decreasing rate. Concave up, like a cup, positive second derivative. Concave down, like a frown, negative second derivative. So concave up means that all of the tangent lines, concave up, lie below the graph. If you're concave down, all of the tangent lines live on top of your graph. So just looking at the picture here, concave down until we get to point B where it changes to be concave up, concave down, cup, cup, frown. Increasing at an increasing rate, therefore the second derivative is positive, concave up. Concave down, you can see the tangent lines are sitting on top of the graph. Now you also have a concavity test. So if the second derivative is positive, then we're concave up. Second derivative is negative, we are concave down. So just looking at a graph, you should be able to look at it and know whether it's increasing, decreasing, concave up, concave down. Points of inflection are where we change from positive concave up to concave down or vice versa. So where you change concavity is an inflection point. So open intervals where we are increasing. I'm going to write my answers down on a sheet of paper here. But I'm not going to draw it. So first we want open intervals where we're increasing. We are increasing from 0 to 1. I'm going to go ahead and make a place to write decreasing. We're decreasing, takes over at 1 and begins decreasing. Here's my local max. It decreases all the way until 3. Then it begins increasing again. It increases boop, 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 to 4 and 5. At 5, it takes a little rest, but it doesn't start decreasing, it just increases after that from 5 to 7. So it only has one little place where it is decreasing. Now, is concave up and concave down? So I'll put CU for concave up, I'll put CD for concave down. Concave down from 0 until 2. It looks frowny. Now it looks happy. So concave up like a cup. Looks like it switches right here at 1, 2, 3, 4. Then it becomes concave down in this little box from 4 to 5. And then when it flattens out looks like it took a rest, and now it starts increasing at an increasing rate and becomes concave upward again from 5 to 7. So it has inflection points at 2, and it is the 0.22. It has an inflection point at 1, 2, 3, 4, 4, 4. And just because it's very consistent, it has an inflection point at 1, 2, oh, actually that was 4, 3, and 5, 4. 4, 3, and 5, 4. So let me make sure. 1, 2, 3, 4. 1, 2, 3. Exactly. And then 5 and 4. I'm going to leave this one for you to do. I'll take a break. I'll do it and write it up, then you can check. Okay, I admit at first I thought this was just a graph of f, and I had to erase when I realized that this is a graph of f primed of x, the derivative. So when it asks where it is increasing, I have to look at where this graph is positive, because when the derivative is positive is where it's increasing. So it's increasing from 0 to 4, and it's increasing from 6 to 8. I went ahead and made myself a sign chart for it, just to kind of illustrate how we can do this. So the top row is easy. I just looked at the graph. Where the graph is above the x-axis, the derivative is positive. Where the graph is below the x-axis, the derivative is negative. The second derivative is a little harder. You have to think about the derivative of the first derivative. Well, the first derivative is positive when it's above the x-axis, but its derivative is positive when it's increasing. So the second derivative is positive where the first derivative is increasing from 0 to 1, from 2 to 3, and from 5 to 7. The second derivative is negative where the first derivative is decreasing from 1 to 2, from 3 to 5, and again from 7 to 9. So it's concave up where the first derivative is positive, is concave down where the second derivative, it is concave up where the second derivative is positive, is concave down where the second derivative is negative. And it has inflection points where it changes concavity at 1, 2, 3, 5, and 7. So at the change points of the derivative, the first derivative, it changes from increasing to decreasing, decreasing to increasing. So positive to negative, negative to positive. I'm going to stop the video here and then we'll start another one.